Hi everyone, we're going to prove that for all permutations whereby P and Q belong to the set N, or set sub N, and our N is a positive integer, that the inverse of Q and P equals P inverse Q inverse. So these are all permutations. So the way you want to do that is just recall also that P times P inverse equals E, which equals P inverse composed with P. So basically what we can do is to prove this is set this up as QP star P inverse Q inverse. Set that up, and we're also going to set it up as P inverse Q inverse star QP. Now, simplifying this, this is the binary operation. So just take away the parentheses and you get Q, P, P inverse, Q inverse. Now this is going to be E right here. So you have Q, E, Q inverse. So E is just your identity. So that's going to be Q, Q inverse, and that equals E. So all this is equals. Now let's do this side. So for this side, do the same thing. So we get P inverse E, P, which equals P inverse P, which equals E. See, these both equal E, so these are inverses of each other. Thus, we have QP star P inverse Q inverse equals P inverse Q inverse times QP equals E. Therefore, QP and P inverse Q inverse are inverses of each other because of the identity. Hence, we have QP inverse equals P inverse Q inverse. And that's it. Thank you. Have a nice day. Bye-bye.